Thank you, Ali. Hope you can see my screen. Sharing. Well, another very exciting day. Good morning, good afternoon, and good evening, wherever you are. I am airing this from the beautiful city of Spain, Barcelona. So it's good night for me. And today's topic is a very interesting one, executing any code in any language with Presto. Though I use the word Presto here, I'm going to explain how we can leverage this capability in Presto. But as such, the concept, a method or approach for executing any code through a SQL engine is being patented by me in the last August. But for today's session, let me explain and illustrate how we can use this in the context of PrestoDB. I am Ravishankar. I am the CEO of PassionBytes. As Ali mentioned, a data guy, worked in various industries. Most of my career had been in financial industry, building next generation data models, data marts, etc., Imon, Kimballs, etc., etc. And one of the most loved software for me is PrestoDB, since it's available as open source in 2014. I started, as I mentioned in one of my last sessions, that in February 27, 2014 exactly was the first talk that I did on Presto, and the version number was 0.59. And today we can see the version number is 0.273, a long journey. And glad and proud to be implementing Presto across various use cases across the globe, some in the largest banks in terms of customers, some in AI companies in United Arab Emirates, some in transportation and healthcare organizations in US, so on and so forth. Before starting, I'm a little bit vexed up with this kind of revolution that is happening in the world. Everybody wants to tell. I think it was started with Amazon, who told that, infrastructure as code. Since then, whenever I read something and whenever I see some software, I see this as code, and I believe that it is a kind of Ascode Revolution, right? So you're all familiar with this. Infrastructure as code, configuration as code, pipeline as code, operations as code, compliance as code, right? So on and so forth. Maybe cooking might be as a code sometime later. We don't know where the technology is taking up, right? And, our PrestoDB is lying here. And is there anything that we can tell in PrestoDB that, any code as an SQL data source or any code through a Presto query? So I was thinking on this particular aspect for a long time. And fortunately, because of the technology's evolutions and the new things that are happening in the industry, I think we are very close. And after today's session, I think you might be able to appreciate that we can start saying that, we can use any code as an SQL data source for PrestoDB. So, what is the main concept behind it, right? So, throughout my career, wherever I was dealing with the data-related implementations and data-driven applications, everybody wants to query the data. All wants to get the data some way into their Jupyter notebook or Zeppelin notebook, or their queries or reporting platforms, Cognos or business objects of the world, or Power BI's, Tableaus, etc. But they don't want a database as such, because today, so many talks we have seen, Parquet files, ORC files, Avro files. There are different kinds of files that are available. Nobody is really looking for a database. Of course, there are so many situations where you need really a DBMS, when you want historical data, when you want archived data, etc., etc. But other than that, the modern world, the modern scientists, the modern analysts, they don't want a database management system, but everybody wants SQL. They want to query the SQL, as Girish told in the very beginning today, that SQL-based engine is what is required for everybody to query the diverse, disparate amount of data. And that is one of the success factors behind Presto adoption. Today, we can put a CSV file or a Parquet file or an ORC file into a cloud-based S3 or a MinIO or Ceph kind of S3. You can expose it as a table using create table as, and then with the location pointing to that particular S3, and you can start querying, right? And not necessarily, I don't know how many of you have used other than Hive Meta Store in Presto. In Presto, you can use a Presto store other than the Hive Meta Store, so that you don't have to rely on really on a Hive Meta Store in order to query S3. And then you can query the data and get the data. But still, we lack something. What we lack is the data is required to be available on a storage. Anything that you query in Presto, except for, let's say, HTTP connector or maybe Kafka connector, you need the data to be available. And even for Kafka connector also, you need the data to be available in that particular brokers. And then you are able to query the data. Now, please think a minute. What happens if, suppose, when I'm running in a particular query, I just want to combine the data to get the current temperature of a particular location? What if you need the current weather data to predict the pricing for a transportation organization? Yes, you can write a custom function, but still, if suppose the number of requirements of such online queries are more, writing custom functions and executing everything within the Presto ecosystem itself may be a little bit tedious. We may need a better approach. And that's where PrestoDB already has got something called a Thrift Connector. And in Thrift Connector, by implementing a Presto Thrift service interface, you can create one or more Thrift servers. You can implement the interface. You can just click on the link to see that interface definition language is available in PrestoDB docs. And you can get the data that you want, provided you are implementing the Thrift server interface, and then you are invoking the corresponding server. But the problem with that approach is, if there are many external systems, then you will need to write that many Thrift servers, each of them implementing the interface to query that external system in the particular way, and then get that particular data. Well, it is a good approach, but can there be a better approach? It seems that if you take out the word thrift, what is thrift? Thrift is a protocol. So let's think about creating a protocol server. And after we create the protocol server, we will attach different existing codes irrespective of the language, C or C++ or Java or Ruby, and we'll attach in a certain language independent format to this protocol server. So consider the protocol server as a registry. And in the registry, we are going to put or register these external existing functions, which is having their own runtime, not the Presto runtime. They're running, they're existing functions. We are going to leverage those functions, and we are going to register them into this particular protocol server. Next important thing is, we will build a connector from Presto to this protocol server. And it is not JDBC, a custom connector, just like Kafka connector or Thrift connector or an HTTP connector. And then we are going to tell that, okay, I want to execute this particular function. And we will map the function to a table name. Maybe a little bit abstract, but hold on. Let me explain you in detail. The first thing, we need to select the best protocol. And we need a language independent data format. What can we rely on? A protocol server. We are going to create a protocol server, register it, and then create a connection to that protocol server. You can use RPC, gRPC, etc., as your protocol server. And now thinking about what is the protocol and what is the type of the language independent format that you require, there comes Arrow. And this is the first implementation that I have done using Arrow because it allows you to have a zero copy data format. It avoids unnecessary serialization and deserialization, and it allows you to manage the data transfer in the most effective way. And fortunately, those who know Arrow knows that there is also a protocol server associated with Arrow, which is Arrow Flight. And Arrow Flight is built on the top of HTTP2 streaming, and it has got all the bidirectional support for the data transfer, parallelism, security, etc., inbuilt. So what should be our approach? We create a connector in Presto for Arrow Flight. Arrow Flight will act as the protocol server, and then whatever existing code is there in any language, and you know that Arrow Flight supports more than 8 to 9 languages currently, you will be attaching that particular functions into this Arrow Flight server so that when you query it using PrestoDB, assuming that you created the connector very well, you will be able to execute that particular function, which is having a separate runtime. Well, in the initial implementations, what I have done is that rather than registering it into the protocol server, I used my own Arrow RDD with Spark to write into a particular directory or mount it onto an S3 based implementation like MinIO or Ceph. And then using Python code or C++ code, you can just load that particular file into a flight server, and the Arrow Flight connector from PrestoDB queries this particular data. So how can all this work? Let us directly jump into a particular demo and look at the functions that are available. First of all, this is the code that is available where Presto Arrow connector, Arrow Flight connector is being made. And inside the connector, you can see that I have just cloned exactly the Kafka connector that is available in PrestoDB. You will see the Kafka column handle. Here I call it as Arrow column handle, Arrow connector factory, etc. And building a connector, we are not leveraging here a base JDBC connection because we are connecting to a flight protocol, not a JDBC protocol. So you will have to write the split manager, the metadata management, etc. In the split, there are some actions that is pending where you will be, deciding the node strategy and assigning the nodes, etc. I just kept it as no preference for now because we have not decided on how this particular execution should happen when there are many workers, etc. So we have got this Arrow Flight connector. It can connect to flight. It can convert it into the corresponding data type. So you have created the corresponding reader and writer packages whenever there is an arrow type coming in the arrow format into the flight server. This particular reader writer will be able to convert it into a Presto specific data type. You know, if you have implemented any JDBC connector, you will have to do this particular mapping. You will be doing it in your connection factory or connection config module when you are extending the connector library, right? Exactly the same thing you will be doing it here. And what's the advantage? The advantage is that you don't need an IDL to be explicitly specified for each connection, just like how you implemented for Thrift Connector. Because you have converting all the protocol basic or protocol specific types into a JDBC equivalent type, It will work with any kind of code that you are writing. Right? So once this is completed, just implement it, and I have added it into a 2.7.4 version. And let me open that, and then we will start the server. As you can see here, let me just quickly show you the catalog directory. Please forget about another connector that is available called a duckdb connector, which I was just experimenting. So if you look at the properties, I have got a duck.properties, which I was connecting for a WASM implementation on duckdb, but that is irrelevant for this. But let's look at the code.properties, and you can see that I created this particular connector called a Sigma, which is connecting to the flight server, and the flight server URL is my local host, and there is a port associated with it, and I have put a maximum buffer size. Of course, you can add the user ID and password, but for this particular demo, I have not added the security part of it. And once you have all these things, the next one is to start your Presto server as usual, and it will be loading all the catalogs, and it will have the inbuilt connector now to Aeroflight. Beautiful. Once the Aeroflight server is there, the next step is to start your Jupyter code. And let me give you the example in Python so that I can explain it with some illustrations. As you can see here, this is the runtime of the client. And I have created a virtual environment which is supporting Arrow. As I mentioned to you, assume that this is the existing client environment or existing code environment, which I am going to leverage from Presto. And Presto is going to call this particular function and leverage the running environment, what is being available now, rather than bringing the processing into PrestoDB. So you got the PyArrow environment, and then we can just look at the code that is getting executed. So let us just look at the code here. What I'm going to do is I'm going to define some functions. Okay, let us write a function to connect to SFTP. Look at that, right? PrestoDB cannot have a connector to SFTP, but I have a function which is existing, which is connecting to SFTP. My user ID, my password, I'm using the Paramiko library in Python, and it is connecting. And as you can see here, on every function, on the last line, I'm converting that into Arrow format. As I mentioned to you, in our flight server, we will be using Arrow as our data format. Arrow flight is the protocol. Then I have got another function called tweets table, which is fetching the data from Twitter, and it is looking for all the tags as big data. Then I've got another function which is reading a website and reading an HTML table from the website. So let me just show you this particular site before going further. So I'm just going here, and then I'm going to click on this. And you can see that this particular website, the Wikipedia, is having a table on the right-hand side, which is showing the election results, right? And in Pandas, you know, you have a library to read this particular election results by giving the table name in the HTML. I'm just showing you the ability of web scraping here, right? So this function is going to this particular site and reading this particular table that you see on the right-hand side, and again, it is converting it into Arrow format. And then I have got the Presto Sigma flight server, and I'm going to start my flight server, and it is serving the flight, right? So once that particular flight server is serving, now you can start your client environment, which is nothing but the PrestoDB client. And then let us start looking at what are the tables inside this particular code.properties. And code.properties, as you know, is making a connection to the flight server, right? So let it execute. And what is internally happening is that it is connecting to the flight server, which is behind the scenes, and then fetching all the data related with the functions registered in the flight server. And as I mentioned to you in the code, let me show you the code again. You can see that there are 4 functions I have registered. One is to get the SFTP data. Another is to get the tweet data. Third is to get the election data from the HTML. And the API table is nothing but reading some APIs. And now let us just write the data from the SFTP table. Look at that. The code is getting executed from the flight server, and it is giving you the real-time SFTP data that is getting read from the machine that I have specified in my code. Similarly, if suppose you want to get the tweets that is associated, you can just write the code.default.tweets, which is now executing the associated code with the Twitter connection, and then giving the data related with the big data. So again, looking at the code, you will see now that those 4 tables are the ones which I have registered as the functions that are to be available from Presto. So whatever I have registered as key and value, the keys are being interpreted as the function names. And you can see here, this is where the flight server is running, and flight is built on the top of gRPC. So by creating a flight server and associated arrow-based format, you got it. Similarly, you can extend it for RPC-based protocols or FTP-based protocols, etc. So we have done 3 implementations of the same concept using different protocols. So coming back to the presentation, the advantages of this particular approach, of course, is you can get in the moment data. Maybe some people will be calling it a streaming, but I will be considering this as better than more better than streaming. And it is not about large amount of data. So many talks today have talked about scale, efficiency, reliability, etc. This is about getting the data in the moment for some decisioning purposes. You know, if metaverse is coming in the future, and if suppose you want to create a metaverse screen where the metaverse simulator screen is showing you a cloud because the current weather is bad or a storm is coming, you can know whether there is going to be a storm or not by using this particular approach, where you will be querying the real-time data and then getting that and combining it with your metaverse painting so that it will give you a little bit of real-life simulation. In one of the largest implementations, where reading COBOL copybooks was practically very difficult without a COBOL language, we were able to do this particular approach and read this WAX file system from Kix. If you want to do such legacy integrations, when you are building your modern data lakes, approach could be of great help. And we have some things to do. One is, as you have seen, that I was giving you the key and value. The key is the table name and the value is the function name. How will I pass parameters? And how can we do a push down predicate as we talk in Project ARIA? How will we pass parameters to the protocol server? And as I mentioned to you earlier, the node strategy is no preference now. How can we apply the dynamic node strategies? And of course, there are some approvals are being pending from the legals before I submit as a PR and put it into open source into the PrestoDB community. So that's all from me this time. Thank you very much for this opportunity. Thanks, Presto Foundation. Thanks, Ali, and entire team. And I do want to, take this opportunity to thank all the community members of Presto for making it a great software, and we will continue our journey. Thank you very much. Any questions?
Thank you, Ravi. Really cool stuff that you've shared. And again, it's been such a fantastic journey for you in Presto, and it's been fun to watch how far it's come since you've started it and where we are today. So thank you for sharing that with us. I do see we have one question here. Will the code be shared in GitHub?
Yes, absolutely. So that's what I mentioned in my last slide, that I'm just working on some small changes, and as soon as it is complete, and please expect it within a month or so, I will submit a PR and then add it as a flight connector. Yep.
Perfect. All right, folks. If there's any more questions, you can pop them in here. Ravi, I guess maybe you'll be around for a few more minutes. If more questions come in, you can go ahead and answer them on the chat itself.
Definitely.
Cool.
Thank you very much.
All right. Thank you, Ravi.